Hello everyone. The solar system is an endless resource brimming with discoveries for astronomy enthusiasts and space explorers. But sometimes some of these fascinating space structures are dwarfed by planets and stars that appear larger and brighter. Mars' two small moons, Phobos and Deimos, are mysterious worlds caught in just such a shadow. This documentary aims to take a journey into the depths of Phobos and Deimos, revealing the fascinating world of these two tiny moons. Phobos and Deimos are like hidden treasures beyond the simplicity and complexity of Mars. The stories of these two moons, named after Greek mythology, have fascinated skywatchers for many years. However, they attract attention not only with their stunning views but also with their close relationship with Mars. While Phobos and Deimos travel next to Mars without ever moving away from its sites, they bring with them many questions while examining Mars. Phobos and Deimos were formed, how big they are, why Mars has these two moons, and many other questions. We focus on the close interactions of these two small moons with Mars. These two small satellites closely and get one step closer to the secrets of Mars and the solar system. Ancient observations are limited, as Phobos has historically been a moon so small that it can barely be seen by naked observations. In ancient times, it was not possible to observe small moons such as Phobos and Deimos because these moons can only be seen using powerful telescopes. Phobos was a remarkable astronomical achievement that took place in the late 18th and early 19th centuries. This discovery is one of the rare examples confirming that a planet in the solar system has more than one natural satellite. Discovery by American astronomer Asaph. It was conducted by Hall at the Naval Observatory in Washington, D.C., on August 18, 1877. Refractor telescope, a powerful telescope, to study Mars and discover its potential moons. He focused carefully on Mars and began to study this planet regularly. In July 1877, he focused on Mars and made careful observations. However, it could not observe any satellites for a while. Continuing his determination, Hall continued to examine Mars on August 17, 1877. This time, he noticed a moon appearing as a dot moving rapidly near Mars. He first described it as a high-speed satellite. The next night, he observed the same moon close to Mars and moving rapidly. After several days of careful observations, Hall discovered on August 18, 1877 that the same moon along with the other previously noticed moons were the moons of Mars. He later named these two satellites Phobos and Deimos, taking their names from ancient Greek mythology. This discovery created great excitement in the world of astronomy and contributed to a better understanding of the solar system. It was previously thought that Mars had only one moon, but Hall's studies confirmed the existence of two moons. The discovery of Phobos provided an opportunity to study the Martian system in more detail and gain more information. Of Deimos was confirmed by subsequent observations, proving that these two moons were indeed natural satellites of Mars. These discoveries led to more information about the nature of Mars' moons, the evolution of Mars and the solar system, and the formation of moons around planets. The discovery of Phobos is therefore considered an important milestone for astronomy and space science and has increased interest in the Martian system. Today, the study of these two moons continues as an important research topic towards a broader understanding of Mars and the solar system. Phobos and Deimos are natural satellites of the planet Mars and orbit around Mars. Phobos orbits very close to the planet Mars. It orbits very close to the surface of Mars, at an average distance of about 9,378 kilometers. This means that Phobos is quite close to the surface of Mars and is rapidly orbiting Mars. Because of this proximity to the surface of Mars, Phobos rotates faster than the surface of Mars and can be observed twice in a Martian day. Deimos lies in an orbit farther from Mars. The average distance to the surface of Mars is approximately 23,460 kilometers. Deimos has a smaller appearance from the surface of Mars because it is smaller and further away than Phobos. Deimos orbits Mars at a slower speed and can only be observed once during a Martian day. The structure and motion of these two moons have helped scientists better understand the history and formation of Mars. Phobos and Deimos are natural satellites of Mars and have their own gravity, but their gravity is quite weak. Since the surface gravity of Mars is lower than that of Earth, the surface gravity of Phobos and Deimos is also very low. Phobos' surface gravity is approximately 0.0057 meters per second squared. This is quite low considering that Earth's surface gravity is about 9.8 meters per second squared. Deimos' surface gravity is even lower, at about 0.0039 meters per second squared. This indicates that Deimos has a much smaller and less dense moon. Low gravity of Phobos and Deimos, it is much easier to jump or move from the surface of these two moons than from Earth. Compared to the surface of Mars, objects on the surface of these moons fall more lightly and move more easily. This could potentially provide advantages for future exploration and colonization projects. Phobos is covered with numerous craters. These craters were formed by impacts of space objects and provide important information about the evolutionary history of Phobos' surface. Stickney crater is the largest and most prominent crater on the surface of Phobos. This crater covers approximately half of Phobos' surface. It is a prominent feature on the surface of Phobos and is named after Asaph. Hall's wife, Angeline, named after Stickney. Hall crater is Asaph's cathedral, which played an important role in the discovery of Phobos. It was named in Hall's honor. Hall crater, Stickney. It is located near the crater. Grildrig crater is one of the large pits on the surface of Phobos. It takes its name from one of the fictional characters in Jonathan Swift's Gulliver's Travels. Roche crater is one of the important craters on the surface of Phobos. This crater may play a role in influencing the formation of other craters. Various scientific studies are ongoing for this purpose. Charlinsky crater is one of several craters on the surface of Phobos and has been documented by various observation instruments. Phobos' surface represent important research topics to understand this moon's age, past impact events, and surface formation processes. Studying these craters sheds light on the evolutionary history of Phobos and the past of the solar system. Therefore, these craters are of great interest to scientists and could be important targets for future Mars and Phobos missions. Phobos has long, narrow ridges on its surface. These ridges appear as raised ridges on the surface, and can sometimes continue through craters. These ridges may have formed as a result of the layering of thin layers of basalt plumes and dust on Phobos' surface. Ridges may interact with craters on the surface, offering important information about the moon's history. Phobos also has rows or grooves on its surface. These rows are distinctive grooves visible on the surface and may have been formed by the sedimentation of basalt plumes and dust onto the surface. Some rows appear as large grooves that cut across the moon's surface. The sequences may provide more information about the formation and evolution processes of Phobos. Various other fractures and cracks are also found on Phobos' surface. These fractures may interact with surface craters and be the result of various geological processes. The surface of Phobos is quite rough. This roughness is caused by the fact that the surface is covered with many craters and consists of hard rocks. Phobos' surface materials provide important information for understanding the structure and origin of this small moon. Surface materials have been determined through various analyses by astronomers and space missions. Phobos cover most of the surface. These plumes are the most prominent material on the moon's surface. Basalt plumes may have formed as a result of volcanic activity, and this material covers a large part of the surface, increasing the roughness of the surface. Phobos' surface contains dust and rock particles. These particles are formed as a result of impacts, surface subsidence and geological activity. These dust and rock particles can cause various color and material differences on the surface. Regolith, a thin layer of accumulated surface dust and rock particles, covers the surface of Phobos. The regolith is an important resource for astronomers to study the surface of this moon and analyze its surface materials. Phobos also has some minerals on its surface, such as carbonate and phosphate minerals. These minerals are used to understand the composition and mineralogy of surface materials. Phobos' surface materials have been an important topic for understanding this small moon's origin, evolution, and interaction with Mars. Different hypotheses have been proposed that it was captured from Mars or had its own local formation, and studying surface materials can help test these hypotheses. Therefore, the surface materials of Phobos represent an important research topic for future space missions and astronomical studies. Deimos is the smaller and more distant moon of Mars, whose surface is quite rough and covered in craters. However, the surface of Deimos is much less known and detailed crater maps have not yet been obtained. Known important craters include Voltaire crater. Swift crater is another large named crater on the surface of Deimos. Swift crater may be an important example of how the surface of this moon was shaped by various geological processes. Some craters on Deimos' surface appear to be broken or cracked. These cracks or fractures may occur during the formation of craters. Deimos is flatter and smoother than Phobos because it is the smaller moon of Mars. For this reason, there are no major topographic features on Deimos, such as prominent ridges and ranges, as on Phobos. However, its surface is covered with slightly wavy and waveless hills. The surface of Deimos has a more homogeneous and flat appearance. Deimos' surface indicates important information about how the small moon formed and evolved. Unlike the ridges and ranges on the surface of Phobos, there are no such major topographic features on the surface of Deimos. Its surface features hold many mysteries that may help astronomers and scientists to better understand the origin and evolution of this moon with further study. Deimos' lack of detailed topographic features such as ridges and ranges suggests that this moon does not have a more complex geological history like Phobos. But future space missions and further investigations may provide more data to unravel the mysteries of Deimos. The surface of Deimos has a gray or gray-like color. This color may depend on the type and composition of surface materials. Its surface is covered with dust and rock particles. The formation of these particles is associated with various geological processes. It is thought that carbonate and phosphate minerals are among some of the minerals found on its surface. These minerals are used to understand the composition and mineralogy of the surface. Small moons such as Phobos and Deimos are highly unlikely to have distinctive topographic features such as large mountains and valleys compared to the main surface of Mars. The size and mass of these two satellites are quite limited and their gravitational effects are very weak. Therefore, they do not have the ability to form large mountains or valleys like the main surface of Mars. Of Phobos, and scientists have developed different hypotheses to understand these structures. Phobos as an asteroid captured by Mars was for a long time one of the most accepted hypotheses. According to this theory, Phobos was captured by Mars' gravity as it wandered through the solar system. Another theory is that the surface of Phobos was formed as a result of a large impact event on the surface of Mars. According to this theory, when an asteroid hits the surface of Mars, the impact could affect the surface materials of Phobos and create these craters and grooves. Stickney crater, one of the largest craters on the surface of Phobos, is so large supports the theory that it was formed as a result of this impact. Also, Stickney other craters, such as Grildrig crater located near the crater, may also be the results of this impact. Rows or grooves on the surface of Phobos have been hypothesized to have formed as a result of basalt plumes cracking. According to this hypothesis, internal thermal activity or geological processes form ridges and ranges. Although there is no definitive information about the structure and origin of Deimos, some theories have been put forward about the structures of this small satellite. The theory that Deimos was an asteroid captured by Mars' gravity was an accepted hypothesis for a long time. According to this theory, Deimos, an asteroid wandering in the solar system, was captured by Mars' gravity and became its satellite. During this capture, various structures on Deimos' surface may have formed. Phobos is the largest moon of Mars and is a very small celestial body with a diameter of only 22.2 kilometers. These small sizes caused Phobos to be under the influence of Mars' gravity and orbit near Mars. Of Phobos is approximately 1072 times 10 to the 16th kilogram. This indicates that Phobos is quite limited in mass. Compared to Earth's moon, Phobos has a much smaller mass and diameter. Therefore, Phobos' surface gravity is quite low and weak enough for humans to walk comfortably on it. These small dimensions and low mass of Phobos are an important factor for understanding the evolutionary history and origin of this moon. Additionally, these small sizes and low mass also provide information about how the materials on Phobos' surface form and change. Future space missions and surveys may provide more data to unravel the mysteries of Phobos. Deimos is the smaller satellite of Mars and is a very small celestial body. Deimos' diameter is approximately 12.4 kilometers. This length indicates that Deimos has a rather small moon. It has a smaller and more distant orbit than Mars' other moon, Phobos. Its mass is approximately 1.48 times 10 to the 15 kilograms. This indicates that Deimos' mass is quite limited. Compared to Earth's moon or Mars, Deimos has a much smaller mass. Of Deimos caused this moon to remain under the influence of Mars' gravity and orbit near Mars. The surface of Deimos is not easily accessible to humans, as surface gravity is quite weak. The dimensions and mass of Deimos are an important factor in understanding the evolutionary history of this moon and its interaction with Mars. Future space missions and surveys may provide more data to unravel the mysteries of Deimos and better understand the origin of this small moon. Of Phobos is estimated at approximately 1.9 grams per cc. This likely indicates that Phobos has a very low density structure. Of Deimos is estimated to be approximately 1.47 grams per cc. This density indicates that this satellite has a fairly light composition. Mars' gravity affects the orbits and movements of Phobos and Deimos. Tidal effects cause these moons to slowly approach Mars. In particular, Phobos may approach Mars and fall to the surface of Mars, breaking apart millions of years in the future. Phobos rotates synchronously with respect to the surface of Mars, meaning it always shows the same face towards the surface of Mars. This occurs due to the gravity of Mars. Deimos rotates slowly, meaning it does not have a fixed surface relative to the surface of Mars. Phobos and Deimos with Mars are an important factor in understanding the evolution of these two moons and the geological history of Mars. Future Mars missions and further observations may provide a more detailed understanding of these interactions. Phobos and Deimos, as natural satellites of Mars, are important targets that have been the focus of attention for manned and unmanned space missions. Different space agencies are planning robotic missions to study Phobos and Deimos remotely. These missions can be used to map the surface of these two moons, study their composition and understand their geological properties. A drone mission could collect samples from Phobos or Deimos and bring them back to Earth. These samples can provide more information about the composition, origin and evolution of these moons. Phobos and Deimos may be used as communications relays for manned Mars missions. These satellites could be useful in communicating and relaying data to established stations on the surface of Mars. These missions could help develop technologies needed for future manned missions. Spacecraft operating in Mars orbit and around its moons can be used as a test platform in preparation for manned Mars missions. Phobos and Deimos may be intermediate targets of manned Mars missions. Astronauts can access the Martian surface faster and at lower cost from these satellites because they are closer to Earth. The idea of establishing a research base on Phobos or Deimos is also being considered. These bases can help astronauts examine Mars more closely and make preparations before landing on the Martian surface. Phobos and Deimos can be used as intermediate stations for spacecraft used to reach Mars. By establishing fuel storage facilities on these satellites, it may be possible to provide the fuel required for landing on Mars and returning. Phobos and Deimos can be used as a platform where astronauts can make their final preparations for going to and from Mars and continue their missions with training in space. On these moons, astronauts can experience environmental conditions similar to those on the Martian surface. Long-duration Mars missions pose serious physical and psychological challenges for astronauts. Phobos or Deimos could be a relaxing station during the journey to Mars that could be used for astronauts to rest, recover, and prepare for Mars landing. These two satellites are potential targets for space resource exploration. Extracting and using resources such as water ice on these moons could be important for future space exploration and colonization projects. Phobos and Deimos have great potential to learn more about Mars and the Solar System more generally, and to provide important transit points for human missions. In the future, these satellites are expected to witness more exploration and reconnaissance missions. Celestial bodies such as Phobos and Deimos are directly exposed to the effects of this solar wind flow. The solar wind is a stream of charged particles from the Sun and propagates throughout the solar system. Since the solar wind consists of charged particles, collisions of these particles can cause energy transfer to the surfaces of Phobos and Deimos. This could lead to energy bombardment and radiation exposure to the surfaces of these satellites. Both Phobos and Deimos are celestial bodies that do not have atmospheres. Therefore, solar wind impacts may cause their surfaces to be directly affected. Charged particles can hit the surfaces of these moons, affecting their atoms and molecules, and these interactions can lead to chemical reactions on the surface. When charged particles of the solar wind hit the surfaces of Phobos and Deimos, ion bombardment may occur. This ion bombardment can cause sputtering and erosion of surface material. Electrical effects can occur when charged particles of the solar wind hit the surfaces of these two moons. These effects can cause electrostatic charging and electrical changes on the surface. These effects of the solar wind may shape the geological features of Phobos and Deimos. In particular, craters, cracks and other shapes on the surfaces of these moons may be the result of long-term effects of the solar wind. Small bodies such as Phobos and Deimos can more easily record the effects of the solar wind on their surfaces because they have no atmosphere and no protective magnetosphere. Therefore, solar wind effects on the surfaces of these two moons could help better understand interplanetary environments and space weather. Various telescopes and equipment that can be used for the observation of Phobos and Deimos. Because these moons orbit Mars and are difficult to observe, they are often studied using remote sensing and space probes. Mars Reconnaissance orbiting Mars Orbiter, Mars Express, and other orbital satellites are used to remotely study and image Phobos and Deimos. These satellites are used to map the surfaces of these two moons, study their composition, and understand their geological features. Large telescopes on Earth can be used to monitor the orbits and movements of Phobos and Deimos around Mars. These telescopes are used to analyze the observation times and orbits of these two satellites. Radio telescopes can be used to monitor and analyze radio signals around Phobos and Deimos. Such observations could provide information about the gravitational effects and orbits of these two satellites. Remote sensing equipment is used by space probes and orbital satellites to examine the surfaces of these two satellites. This equipment is used to perform imaging, spectral analysis, and other scientific research. Phobos and Deimos are two moons on Earth that are neither bright nor large enough to be observed through a telescope by amateur observers and professional astronomers. It requires a medium-sized telescope to be observed by amateur astronomers. It may be possible to observe these two satellites with a telescope with a diameter of 100 m or larger. Since Phobos and Deimos orbit Mars, they can be observed with a telescope depending on the position of Mars. Therefore, it is important to pay attention to Mars' position in the sky and its suitability for night observation. Because they are so close to the surface of Mars, they appear as a reflection of the sunlight illuminating the planet's surface. Therefore, the visibility of these two moons is better when they are on the surface of Mars at night. Phobos and Deimos appear as small dots when observed through a telescope. Ideally, the observer uses a telescope and appropriate observing equipment to determine Mars and the positions of these two moons. NASA has carried out a number of missions and studies to study Phobos and Deimos and to better understand the Martian system, and some of these studies are still ongoing. Mars Reconnaissance Orbiter is a spacecraft orbiting Mars and has been used to study Phobos and Deimos. MRO examined the surfaces of these two satellites using high-resolution cameras and spectrometers. Mars Odyssey is another NASA spacecraft orbiting Mars. This instrument is used to study the surface of Mars and surrounding moons. Observations of Phobos and Deimos were also carried out within the scope of this mission. MAVEN, or Mars Atmosphere Oath Volatile The Evolution mission is a remarkable work. MAVEN is a spacecraft designed to study the atmosphere of Mars. This mission investigated the effects of Phobos and Deimos on Mars' atmosphere and examined the effects of the solar wind around these two moons. NASA is making preparations for the future Mars Sample Return mission. This mission aims to collect samples from the surface of Mars and bring them to Earth. These samples can also be collected from the surfaces of the Martian moons Phobos and Deimos. Don't forget to subscribe to the Pursuit of Science YouTube channel for brand new documentaries and more scientific content.